I'm Marie Griffin, and I'm here to teach you about Lesson 4.1 vocab congruent figures. One of our vocab words for today is congruent polygons. They are figures that have the same shape and size. First, we'll show which sides are congruent. So, we have AB is congruent to FE. Next, we'll do side BC is congruent to EG. Our third congruent side is CD is congruent to GH. Last but not least, our fourth side, DA, is congruent to HF. These tick marks represent that the sides are congruent. Now I will show you the congruent angles. Angle A is congruent to angle F. Angle B is congruent to angle E. Angle C is congruent to angle G. And angle D is congruent to angle H. These marks show which angles on each figure are congruent to each other. They are called congruency marks. Let's do a practice problem from the book. Complete the congruent statements. As you can see, our congruent statement is triangle LMC is congruent to triangle BJK. For example, angle L is congruent to angle B. Or side LM is congruent to side BJ. Problem 1 is asking which side is congruent to LC. So if you go over here, LC is congruent to BK. Second problem is asking which side is congruent to JB. So we go over here, JB is congruent to ML. The last problem is asking which side is congruent to KJ. We go over here, KJ is congruent to side CM.
Good afternoon. My name is Lauren Teeter, and I'm here today to teach you about Theorem 4.1, also known as the third angles theorem. Theorem 4.1 states that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. For example, it is given that angle L is congruent to angle E, and that angle O is congruent to angle N. So, by the third angles theorem, angle R must be congruent to angle T. Like mentioned before, these congruency marks show that angle L is congruent to angle E, and that angle O is congruent to angle N, and also that angle R is congruent to angle T. Now we're going to try using the third angles theorem in a proof. In this proof, we are given that line segment AB is parallel to line segment DC, angle B is congruent to angle D, line segment AB is congruent to line segment DC, and that line segment BC is congruent to line segment AD. We are trying to prove that triangle ABC is congruent to triangle CDA. First, we'll start with the given. Angle B is congruent to angle D, and that is because it's given. It's congruent to angle D, and the reason for that is because it's given. It is also given that line segment AB is parallel to line segment DC. So for number 2, we'll write line segment AB is parallel to line segment DC. And the reason for that is because it's also given. Step 3 is angle BAC, so that would be this angle, is congruent to angle DCA, which is this angle. And the reason for that is because they're alternate interior angles. So right here, we'll write angle BAC is congruent to angle DCA. And like I said before, it's because they're alternate interior angles. Step 5 would be line segment BC is congruent to line segment AD. And also, AB is congruent to line segment DC, and that's because it's given. So right here, we would write BC is congruent to line segment AD, and line segment AB is congruent to line segment DC. And the reasoning for that is because it's given. Step 4 is angle BCA is congruent to angle DAC. So that would be this angle is congruent to this angle, and that is because the third angles theorem. So for step 4, we would write angle BCA is congruent to angle DAC. And of course, because of the third angles theorem. Step 6 is line segment AC is congruent to line segment AC, and that's because of the reflective property of congruence. So AC is congruent to line segment AC because of the reflexive property of congruence. In conclusion, step 7 is triangle ABC is congruent to triangle CDA. And that is because the definition of congruent triangles. So at the bottom we write our final statement, which would be triangle ABC is congruent to triangle CDA. And our reason is the definition of congruent triangles. Hello, my name is Anna Jones, and today we will be working on lesson 4.1, specifically on practice problems from our book. The first problem we will be working on today is question number 30. The question asks, can you conclude that the triangles are congruent? Justify your answers. Well, the triangles are indeed congruent because there are two marked congruent sides with these little hash marks right here, see? And then TK is congruent to TK by the reflexive property of congruence. So we can mark that right there. Now, it is also given that these angles are congruent, so that makes one pair of congruent angles, and these pair of angles are congruent, so that's two pairs. And if you remember earlier when Lauren was teaching us about the third angles theorem, you would know that if two angles of two triangles are congruent, then the third angles must be congruent by the third angles theorem. So, now we have three pairs of congruent sides and three pairs of congruent angles. So, our triangles are indeed congruent because they have three pairs of congruent angles and three pairs of congruent sides. So, yes, these triangles are congruent. The next problem we will be doing is problem number 35. Problem 35 is asking, find the measures of the given angles or the lengths of the given sides. So, we are trying to find the given angles of triangle ABC and triangle DEF. Now, these triangles are given that they are congruent. So, as a congruence statement, this is a congruent statement. The congruent statement tells us that angle A should be congruent to angle D. So, we are given that the measure of angle A is equal to x plus 10, and that the measure of angle D is equal to 2x. Now, because the congruent statement says that angle A should be congruent to angle D, then the measures of those angles should also be congruent. So, now we have to solve for x and then plug it into our equation to find the measure. So, if the measure of angle A is also congruent to the measure of angle D, our equation should go like this. X plus 10, which is the measure of angle A, is equal to the measure of angle D, which is 2x. So what we're going to do next is we want to get x on one side of the equation. So we are going to subtract x from the left side, or from both sides, because what you do to one side, you have to do to the other side. So these x's cancel each other out. So you're left with 10 on the left side. So 10 is equal to 2x minus x. It gives you x. So now you have 10 equals x, or as you could write it, x equals 10. So we found x. Now what we want to do is we want to plug it in to one or both of the equations. So what we're going to do is I will use the measure of angle A, that equation, so it would be x plus 10. Now, as we found down here, x is equal to 10, so we are going to say, we're going to substitute x for 10, and 10 plus 10 equals 20. So, the measure of angle A is 20. We can also do the measure of angle D equals 2x, so we can substitute x for 10, and then that equals 20. So, the measure of angle A is equal to the measure of angle D, which is equal to 20. So, there you go. Well, that concludes our video for today. Thank you for watching, and we hope you enjoyed it as much as we enjoyed teaching. Just like the board says, bye-bye.